Alright, so in this video what we will do is we're still dealing with sums of series. The difference now is that we are being given the sum. In the prior examples we had to find the sum. Now they're giving us the sum and we have to go backwards. We have to find the number of terms, which means we have to find n, this number right here. Okay, so it's really the same type of thing. The difference being obviously that they're giving you different information, but the procedure is still the same. So we'll practice using both of these formulas. It's not completely important which one we end up using. So let's just use this one first. And this one tends to be easier because we should kind of preferentially stick with this one because unless they give us the last term, because in this one they're giving us the last term but they're not giving us n. In this formula, the second one, they're giving us n, and that's what we're being asked to find. Okay, so we'll use this formula. So I'm going to plug in for this, I'm going to plug in negative 12.4 equals, and then actually, I'm sorry, I misspoke there. We're using this formula right here. So right here, I'm going to plug in negative 12.4 for S sub n. A sub 1 is this right here. It's negative 0.4. And then afterwards, we have to plug in 1 minus r, and r is 5 right here. They're telling us it's 5. We don't know what n is, so we're going to leave it as n, and then 1 minus r on the bottom will be 1 minus 5. Okay, so we'll continue this. So negative 12.4 equals, this is still negative 0.4. Okay, and then the bottom 1 minus 5 is negative 4, so we have 1 minus 5 to the n. Okay, our goal right here is we want to isolate the n. That's the goal of this process. Okay, the goal is to isolate the n, so how can we go about doing this? Well, a couple things we can do. Let's start by simplifying this. So this 0.4 over 4 right here, the negatives will cancel. So the negative times the negative will cancel. And then 0.4 over 4, that could reduce down to 1 over 10. Okay, so we can cancel this and this becomes a 10. Now how do we cancel out that 10? This expression, let me rewrite it so it's a little bit neater. So we have equals, and now we have 1 minus 5 to the n over 10. How can we cancel out the 10? It's being divided by 10, so we can multiply by 10, and we can multiply this by 10. So negative 12.4 times 10 is negative 124. That's equal to 1 minus 5 to the n. Now what we need to do is subtract 1 from both sides. We get negative 125 equals negative 5 to the n. Now keep in mind the negative 5 to the n is not, that's actually not the number negative 5. That's like negative 1 times 5 to the n. Okay, so there's a difference there. We need to get rid of, we haven't quite isolated the n yet. We need to divide this by negative 1, and now it's isolated. So 125 equals 5 to the n. And now you can do a couple things. You could take the logarithm, that's from a previous section, or this is not that hard to look at and see 5 to what power is 125. Well, 5 to the first is 5, 5 to the second is 25, 5 to the third is what we're looking for. It's 125. So that means n in this case is 3. So if we go back up here, okay, the answer to this, the number of terms, is 3. And let's just test that out. Our first term is negative 0.4. Then we're multiplying by 5 each time. So 5 times negative 0.4 is negative 2. And then 5 times that is negative 10. If you add these three terms together, negative 10 plus negative 2 plus negative 0.4, you will in fact get negative 12.4. So I encourage you to try to pause the video and see if you can do numbers 2 and 3. Obviously number 3 is sigma notation. Number 2 is giving you the first 4 terms. Okay, so we'll stick with this formula. This is kind of the easier one to use. We don't have the last term right here, and so this is going to tend to be the easiest one. So same thing, we need to plug in S sub n, which is negative 7812.4. That's equal to A sub 1, which they're telling us once again is negative 0.4. Okay, now you might recognize this. This is actually the same original sum that we just did, but the difference is now our final sum is not negative 12.4. It's a much bigger number. So in this case, we're going to have a different number of terms. And it's still valuable to do this example because you're coming at it with a slightly different amount of starting information. Okay, 1 minus r. Now we don't know r, but we can find it by seeing what am I multiplying by each time. So negative 10 divided by negative 2, that's equal to 5. And that's the same with negative 50 divided by negative 10. So r is 5 once again. And we already knew that from doing the prior example. Okay, same type of approach though, really. There's very little that's different about this problem. We're going to just get a larger number of terms. We already know from the last example that the negatives, this whole thing was -4 and the negatives cancel, and we know that that is the same as 1 over 10. So we're going to have this. We're going to have 1 minus 5 to the n, and that's over 10. We can cancel out the 10 if we multiply this by 10 and this by 10. So here's what we will end up with. We will end up with, on the left side, negative 78,124. And that's equal to 1 minus 5 to the n. Once again, we have to subtract the 1 from both sides. And then we also have to divide by that -1 in front of -5. So that will cancel, and this now becomes positive 78,125. So 78,125 equals 5 to the n. If you want to do this on the calculator, I'll just remind you how to do it with logarithms, because this one, you know, it's be kind of a pain to do some of these by trial and error. So the easiest way to do this with logarithms is to take the log of this side. Doesn't matter what log you take. We'll just do log base 10, and whatever I do to one side has to be done to the other. Okay, this is a good refresher from the logarithm chapter. The property for logarithm says if you take the log, you can now move this in front. So it becomes n times the log of 5. And if I don't write what the base is, I'm not going to write base 10 because the calculator assumes that it's base 10 unless you tell it otherwise. So we'll keep it as base 10. Now how do we solve for n? We need to divide both sides by the log of 5, because that's a number. So we'll divide this by log 5, and we'll punch that in to see what we get. So we had the log of that big number, 78,125, and then I have to make sure to close this and divide it by a completely separate log. You don't want to put those two numbers in the same one, and you end up, let me just slide it over so you can see it. You end up getting 7 terms right there. So that is how many terms. Okay, this sequence has, or the series has 7 terms. All right, last one is using, way back up here, it took us a lot of work to do that. Last one is using sigma notation. So here's our formula once again, and we know that the sum is -21. That's what that means. So -21 is equal to a sub 1. So let's find a sub 1 by plugging in this number, by plugging in m equals 1. So if we do that, we'll have -2 raised to the, and I'm plugging in 1 right here, so 1 minus 1, that's equal to 0. Anything to the 0 is just equal to 1. So our first term in that series is equal to 1. And then we'll finish this. We have 1 minus, remember that this number right here, that's the r value, that's the common ratio. So 1 minus r is 1 minus -2, and on the top 1 minus parentheses -2 to the n. Why am I putting parentheses? Because otherwise we are likely to get confused on the order of operations here. I need to first take -2 and raise it to the n, and only then subtract it from this 1. So let's simplify that. So -21, we don't need the 1 there because 1 times anything is itself, so we'll ignore that. Minus -2 is like +2, so that's 3, and then we have 1 minus, again, -2 to the n. Let's get rid of the 3 by multiplying both sides by 3. So that will cancel. This times 3 is going to give us a value of -63. So now we have this. We have -63 equals 1 minus this. Okay, let's subtract 1 from both sides. We'll get -64 is equal to -2 to the n. Now here's the difference between the last problem. The last problem was -5 to the n. It said 1 minus 5. This one said 1 minus, and now our number actually is negative, our common ratio. So I'm not able to divide both sides of that by -2 because it's not -2 to the n. It's actually the number -2 to the n. So what can we do? Well, we can do the log again, or hopefully we know some powers of 2, because this is a pretty small power of 2. Exponents get large pretty quick. So 2 to the 4th is 16, 2 to the 5th is 32, and you can probably already tell that the next one is going to be 64. And actually, this is going to be -2 to the 6th, but a negative number to the 6th power is still equal to a positive. So our value is n equals 6 terms in that series.